Okay, welcome to the final section of the course, section 9.3, quadratic inequalities in two variables. So let's finish off the course. This is going to be very similar to 9.1 actually. Okay, so this is going to be similar to 9.1. We're going to go back to graphing, but this time the boundary will be a quadratic. So once again, I outlined the four cases that can occur. Don't worry too much about them, but there's the algebraic representation of the four forms that can happen. And like I said, the solution region will be separated by a quadratic boundary, which will look like this. So here, this is a dotted line, which means something like this was used, okay, less than or greater than sign. The boundary is quadratic, and to tell what the solution region is, here I tell you that you can just pick a point and from either above or below the boundary and plug it in and see if it satisfies the inequality. If it does, then shade that region as the solution region. Same as 9.1. Exactly the same. Again, you can simply look at, for this example, you can look at the sign, that's less than. So y is less than this boundary, therefore it has to be below the boundary. Okay, so you don't actually have to use a point if you can see that. And that's it. So all you have to basically know how to do is graph. So the hard part is graphing the boundary. But this is Chapter 3, right? So this is a good review for the final exam in terms of how do you graph quadratic equations. So let's take a look. And I give you very detailed, explanations how to do this in the example. So please take a look at the example before you go ahead and, I did two examples for you right away. But here we go, and let's take a look at practice 1. Graph y is less than or equal to negative x squared plus 2x plus 4. First of all, this is in standard form. And we really want to move to vertex form because it's important to know the vertex, right? Important to know the vertex, and we're going to figure out what the y-intercept is right now. Okay, so that's the benefit of standard form. The y-intercept is 4. Other than that, there's not much we can get from that. Now we have to complete the square. So I'm going to factor out that negative from the first two terms. And then I should write this down. I'm completing the square here. Remember, completing the square moves you from standard form into vertex form. So if you had a weakness here, you gotta iron that out. So step 1 is factoring out a, which is -1 here from the first two terms. Then you're going to take half of the x term, which is -2. So half of -2, will be -1. Square it, which will give you +1, and add and subtract it. Okay, so therefore these two steps are exactly the same. They're exactly the same. They're equal to each other algebraically. However, now I'm going to take out this guy. He's going to come out. This negative out front multiplies to him to give you +1 plus 4. This is a perfect square, x minus 1, and plus 5, okay? So I kind of outlined that. You can pause the video at this point and just analyze the steps that took me to get to, this is vertex form. And in vertex form, v, you can get by inspection, which is 1 and 5. So we have the y-intercept, we have the vertex. It is also useful to get the x-intercepts, okay? The x-intercepts, there could be two. And you do this by making let y equal 0. Solve for x, right? Just like normal. So when you make y equal to 0, I'm going to work from the vertex form because it's quite easy. Where are we? This is vertex form. So when y is 0, we have negative x minus 1 squared plus 5. Move 5 over, you get negative 5 equals negative x minus 1 squared. Now we're going to divide by negative 1 to get rid of this guy out front. So it gives you 5x minus 1 squared. Now you square root both sides to give you root 5 equals x minus 1. This is plus or minus root 5, that is. Therefore we're going to get x equals 1 plus or minus root 5, which comes out to be roughly x is 3.2 and x is approximately negative 1.2. Now we have all the information we need to graph. I'm going to put all these points on. Okay, 3.2 is roughly here. Hey, stop that. Roughly here. Negative 1.2 is roughly here. Sorry, I can make these dots a bit bigger. Then where are we? The y-intercept is 4. Okay. The vertex is 1 and 5. Now, since I'm going to put this next point, I'm going to put down in green. Since, remember, this is the axis of symmetry. Write down the vertex. So we know that this point has to be there from the y-intercept. So you can see just because we have so many points, it becomes very nice to sketch. So there you have it. That is the line y equals negative x squared plus 2x plus 5. Now you just have to determine, do you shade below or above? Because we have a less than or equal to sign. Oh, by the way, this means we're going to have to use a solid line because it was an equal to sign, just like in section 9.1. Now, do we shade above or below? Y is less than or equal to negative x squared plus 2x plus 4. Obviously, it's going to be below. But let's check using a point. And I can use the point 0, 0. So check 0, 0. Plug that into the inequality. We get 0 is less than or equal to 4 is what you're going to get, right? Which is obviously the case. Yes. So therefore, your solution region, which I'll do in green, say, will be everything underneath this guy. That is the solution region. There you have it. Okay. So that's basically it. So the next example will be slightly easier because we're in vertex form. So I started with the tough one, actually. This is the toughest it can get. Here we're in vertex form, so you don't have to complete the square, which many of you will rejoice, including myself, because it saves a lot of time. That's why vertex form is very useful to graph. So there we have it. Okay, that's the vertex. But when you're in vertex form, you can't immediately get the y-intercept, so I'm going to find the y-intercept by letting x equal to 0. So y is going to be equal to negative 4 squared minus 2, which is equal to 14. For the x-intercepts, I'm going to let y equal 0. And when you do that, you get 2 equals x minus 4 squared. Sorry, I moved this 2 all the way over when I made it 0. Then when you square root, you get negative root 2 x minus 4. So x equals 4 plus or minus root 2, which translates to be x is approximately 5.4 and x is approximately 1.8. Let's place those points on the graph. 1.8 roughly here. 5.4 roughly there. Those are the intercepts. The y-intercept is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since it only goes up to 10, I'm going to have to go up by 2s. So this will be 2, this will be 4, 6, 8, 10, 12, 14 will be right here. And we need the vertex, which is 4 and 2. 4 and 2. I'll make that one nice and big. Okay, and I made a mistake because it makes no sense at all. 4 is for x. 3, 4, and 2. Which looks something like that. And you can tell I'm on my third video here of the day because it's 4 and negative 2. 4 and negative 2. Which would be roughly right here. Once again, we can draw our axis of symmetry about the vertex. And we can see we have 1, 2, 3 away. 1, 2, 4 right here would be the corresponding point for the y-intercept. And since we are using we don't have the equal to, so this is a dashed line, right? Because the boundary is not included in the solution. So what this looks like is something like that. Y is greater than the boundary, therefore we're looking at this region right here. You can use a test point, any point you want. You can use a point on the x-axis actually. You could use the point 3 and 0. Right? That would be this point right here that I scribbled so aggressively, which would be 0. Is that greater than 3 minus 4 squared minus 2, which comes out to be 1 minus 2, which comes with a negative 1. Yes, it is. Therefore, it works. Okay? So there you have it. Okay, I wouldn't suggest you scribble as like I'm doing here. I would suggest you just do solid lines like I used to do instead of this mess. But you get the idea. That's basically it. There's nothing else to this section. Let's do a practice problem that will include an application, okay? Similar to the application I did in the example. So here we go. Sport climbers use a rope that is longer and supports less mass than a manila rope. The rope can safely support a mass, m, in pounds, modeled by the inequality m is less than or equal to 1,240 times d minus 2 squared, where d is the diameter of the rope in inches. Graph the inequality to examine how the mass that the rope supports is related to the diameter of the rope. Basically, if the diameter gets bigger, it can support more mass. This is a direct continuation from example 3 here, which dealt with manila rope. So, the question is asking you to graph this and graph the solution region, and that's pretty much it. It just gives you some context to how you can apply this stuff. Given this, you're in vertex form actually. That's vertex form. And which implies that the vertex is 2 and 0 because you don't have a term on the back side of here. You might want to find the m-intercept, and I kind of rewrote the axes here. So y is m in this case and x is d. And the m-intercept will be when you let d equals 0. So then you're going to have m equals 1,240 times negative 2 squared, which comes out to be 4,960. And then for the d-intercept, that's pretty easy. If you let m equal 0, then d will simply be equal to 2 when you solve for it. So from here you can very easily graph the inequality. One other thing you might want to have is the y-intercept, one other thing you want to have is a proper scale. So I'm going to change the scale here. So the proper scale, because this is so large, and this is actually kind of what I'm doing in this question, can kind of sometimes throw people off, and this is a small value, okay? Don't be afraid to change the scale on the axes. So for instance, if I actually go up by thousands for m, so 1,000, 2,000, that's 3,000, and this would be 4,000, that's 5,000. Okay, and then on this axis I can go up, let's say that's 1, and this is 2, and this is 3, and this is 4. Remember, I'm actually going to be principally interested in the quadrant 1 here. Then we can graph this quite easily, because 4,960 is basically close to 5,000 when I sketch this. It's going to be right there. The intercept for D is right here. There's only one x-intercept. This is an interesting one because it's just touching the axes. So you can use your nice axis symmetry to get you that. We have an equality, which means a solid line, so the boundary is included in the solution. So here's what it looks like. Okay. Remember, m is less than this whole graph. So basically what you're dealing with is everything over here. Okay, you're dealing with all this other stuff, not greater than. But we are dealing with real values here, right? Real measurements for diameter, real measurements for mass. So really, we only care about, look at quadrant 1. So really what we're looking at is this right here and this right here. Okay, so that's basically it. So you can test this. You can test this by picking, say, 0 and 0, the point 0 and 0. So 0 less than or equal to 1,240, 0 minus that, and of course this is going to be 0 is less than 4,960. That will definitely work. Okay, so we're definitely on the right track here. And if you want to actually understand what this means, if you pick a point, say you pick a point like, let's pick 1 and 1,000 right here, right in the middle. 1 and 1,000. Okay, the point 1 and 1,000 basically means if you have a diameter, if the diameter is of the rope is 1 inch, that implies it can support a mass of 1,000. Supports 1,000. And are we in pounds? Yeah, 1,000 pounds. Okay. 1,000 pounds and anything under 1,000 pounds. So obviously 900 pounds. Its maximum is 1,000 pounds. That's what that means. Okay, so it's a very nice visual representation of the range of solutions that this inequality presents. Okay, so that is the last video of the course, last section of the course. So work on this, complete the practice problems, complete the assignment, then move on to the Chapter 9 exam.